What I'd like you to do, Darren, is to take about a teaspoon or so of this starch and put it over there in that water.
All right.
Okay, stir it up. Not all will dissolve, but enough will.
Okay.
Okay. Now, here's some iodine. Take a half a dropper full and put it in there with the starch.
Oh, it's turning a blackish color.
Yeah, sort of a blue-black. Now, what you've just done is a chemical test. When scientists want to know whether starch is present, they add iodine. If it turns that blue-black color, they know starch was present.
Okay.
If they know the iodine, but they don't, in other words, anytime they put the combination of starch and iodine together, they get the blue-black. So you can tell whether something has starch in it or iodine in it.
Okay.
So now you are going to have to do a similar test. Here are 3 glasses. One has starch in, one has sugar, and one has salt. And I have the labels around on the back side so you can't see them. So tell me, how are you going to find out?
Well, if I put the iodine in the starch container, it'll turn blue-black.
Okay, so try the first one over there.
Well, it's turning an orangish color.
Say, iodine color.
Yeah, it's sugar.
Okay,
Okay.
try the next one.
Oh, it's orange again.
No starch?
No starch. That's salt.
Okay.
So I think this one should be starch.
And it should then do what?
Turn blue-black.
Okay,
Yeah, there it goes.
sure enough.
It's starch,
Starch.
all right.
Well, now, while that chemical test is useful, it's also the basis for a very spectacular chemical stunt, which I'd like you to do. Come on over here.
All right.
Here are 2 glasses, sort of half full of the tube. There's starch and iodine present. So go ahead, mix them, pour them back and forth about 3 times.
Okay.
Where's the blue-black color? I said starch
It's
and
not
iodine
there.
are present.
They haven't mixed.
No, they certainly, maybe, do you think there was something wrong?
Oh, there might have been.
Not at all, because watch.
Oh, there it goes.
All of a sudden, the whole thing turned blue-black. Now, the reason for that is the 2 chemicals that I had in the glass have various kinds of chemicals in them. When you mix them together, the starch and iodine aren't released immediately. It takes a while for a chemical reaction to take place. And you can vary it by changing the temperature or the acidity and make it come out. And you didn't notice it, but I had a stopwatch on it. 16 seconds.
All right.
It
So
took
they're
for-
reacting to each other, but just gradually?
Well, they don't really release all of it until at the end of the 16 seconds, then it's all released at once, and that's why it turns blue-black.
Okay.
So over here are those same 2 solutions.
Just in bigger pitchers.
In bigger pitchers, right. I'll start my stopwatch when you mix them together. Mix them once over here like this, and then if you're very careful, at the time when I get to close to 16, if you're pouring like this, what should happen?
It'll turn blue-black.
That, the whole stream, and this all at once.
All right.
You ready?
Yep.
Okay, I'll start the watch as soon as they hit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15.
Oh, there it goes.
So you now have done probably one of the most famous chemical demonstrations called the clock reaction. You can see why they call it that, can't you?
Yep.
Happens just like that. Ashley, I'd like you to close one eye and without moving, just turn around and look over toward me and tell me what you see.
Well, it's a wooden triangle. It's just that one arm of the triangle is coming toward me, and then the other one is going away from me.
So it's impossible.
Right.
That's
like
why
they
I call
couldn't
it
join.
Yeah, an impossible triangle. Well, come on over here and take a look at it. And you see that your description is pretty good. This arm was definitely going away from you, and that arm is going toward you. Now,
Yeah.
you've seen optical illusions, something like this, haven't you?
Like there's one that has 3 bars coming down, and then there's only 2 bars at the bottom.
Right, and then there's other that are pictures of stairs going up, and they join,
Yeah,
except
and
it's
waterfalls
impossible.
that are-
Waterfalls that go all. Well, this is the same idea, but it is in 3 dimensions. And what you have to do is, see, there's a notch up here. Okay. What you have to do is stand back over there, look with one eye, and line it up so that this piece fits right in that notch, and suddenly it becomes a triangle because your mind says that in spite of the fact that one is going forward and the other back, it must be a triangle because you think they're joined.
Right.
So go back there and see if you can get it lined up.
No, gotta move this way. Ah, there. Perfect. Yeah.
You can see why it's called the impossible triangle.
Mm-hmm.
You don't often think of common objects as works of art, but this mystery object illustrates the artistic idea that form is determined by function. Its form is a simple inclined plane of hard metal. As it turns, it pushes material along. Its function is to drill a hole in a piece of wood. Bibi, here's a nice science experiment that you can do at home. You get a bottle like this, and here is a one-hole stopper. You can use a cork. In the bottom, you put a soda straw. And in the other end, you put the plastic end from a medicine dropper. When you put it on nice and tight like that, what you have to do is blow into here and see how many bubbles of air you can bubble through the liquid at the bottom. You want to try it?
Okay.
Okay. Blow and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's about it. Okay, stop. Let go. That's as much as got you all wet.
Yeah.
That's why I told you to wear old, remember when I said to come over and wear old clothes?
Yeah.
Because I didn't want you to mess up your nice clothes. It's just plain old water, which I put a little coloring in.
Okay.
You all right?
Yep.
Here, wipe off your glasses. Because I thought maybe you'd like to know how to do this trick so you can play it on somebody else.
Yeah.
Who would you like to try it on?
My big sister Miriam.
Okay, so here's what you do now. What's happening when you blow in there? When you blow air in here?
It's going down.
Yeah, and bubbles up here
yeah.
through the water. So what happens to the air pressure here?
I don't know.
You get bigger. As you blow more and more air in here, you get more air in here, so it pushes down on the liquid. Then when you let go of the pressure up here, the air in here pushes out, and out comes a stream of water.
Oh.
So what? Here, I'll try it. Then back away. So you know how to do it now?
Yeah.
Okay, take the bottle home, and whatever happens to you, don't blame me, okay?
Okay.
Right. Okay, Ryan, look in the mirror and tell me what time it is.
It's, well, according to the hands, it's about 5 to 8.
Yeah.
But everything, all the numbers are reversed and backwards,
Mm-hmm.
except the 1 and the 11.
So what time is it really, do you think?
5 after 4.
Right,
about.
5 after 4. In fact, every
Yeah.
time you look in the mirror, you see things backwards, but you look in the mirror so many times and so often, and you only see it in the mirror that many times things are reversed and you don't even realize it. So we're going to have fun today experimenting with various mirror combinations.
Okay.
Now you could ordinarily use little mirrors like these.
Yeah,
You know,
those
you
are
can find
pretty
those around
common.
the house a little easier. But I'm going to use the big ones so we can have we can both see it.
Yeah.
Here's something that's kind of interesting. See what it says?
says Mr.Wizard, but everything's backwards.
Yeah, it goes this way. Well, the M's not
the
backwards.
M and the W and the I and A aren't backwards.
Right. Why would they want to make type backwards? This is the type that they used to print headlines.
Maybe they want to see it in the mirror.
Well, that's
Or,
true. Here, take it once and take a look at it. If you look at it in the mirror,
Says, yeah,
it's all correct then, right? But
Yeah.
that's not why they want to do it. See, the Z is now correct and the D is correct.
yeah.
But, well, now think about this. They put ink all over this. Then they put it down on the paper, and they press on it real hard like this. And then when they pull it up,
It's the right way
it's
on
the right
paper.
way. That's right. So
It's a
type.
stamp.
Yeah. Now, as long as you have a mirror, you can have lots of other fun. Here, take this mirror and hold it up like this, like that. And I'll get another mirror so that you can see what you see. What do you
I
see?
see.
No, don't tip it so far. Just a little bit. Just about like
I
that.
have a small chin. I got
Now you got two mouths.
2 noses.
Right. So when you find a single
I have
mirror
2
around the
chins.
house, you can have fun looking in the bathroom
Yeah.
mirror and see all kinds of weird faces, all of them yours. Okay?
Yeah.
Now, the next thing to do is to get 2 mirrors and tape them together. And here, put the clock out here, and I'll put this mirror around here. And now, move the 2 mirrors until you can see just one image of the clock.
There, right there.
Yeah, what time is it?
Now it's about 7 after 4.
7 after 4, and
Yeah.
it's not reversed.
No.
Why?
Well, the 4 from this side is going over here and over here and back to my eye.
Right, so each side is reversed.
Yeah.
And now you can see yourself like other people see you. Here, look, take a look at yourself and move the mirrors around until you can see just one face, and that's the way you really look.
Doesn't look much different.
Then as long as you got 2 mirrors taped together like that, you can make what I call a 2-mirror kaleidoscope.
Okay.
See, get a piece of paper like this with all kinds of squiggly lines on it.
Yeah.
And lift it up.
Looks pretty random.
And I'll put it underneath like that. Now, see what you see?
It looks like a kaleidoscope.
Yes, except you only have 2 mirrors.
Yeah, so you
see.
can increase the number of shapes and decrease it and everything like that.
Right. That's that one. Then here's another one. See what this one looks like?
Huh.
Okay,
It's
you
not
want to pull
long.
that one out of the way and I'll put this one down? Okay, now take a look at that.
That looks good. Nice
Yeah.
and colorful.
All kinds of weird, colorful lines.
Yeah.
Then, how old are you?
10.
On your birthday, you should have 10 candles, right?
Yeah.
Well, I only have 1. And I'm going to light it and put it between the mirrors. You think you know what to do?
Yeah, I guess so.
Okay. Keep turning until you can count to 10. 10 candles.
10 right
10?
there.
Okay, happy birthday.
Thanks.
Now, ordinarily, when you see a kaleidoscope, how many mirrors does it have?
3.
Well, you can take a 3rd mirror and put it like this and look down and see all kinds of weird design.
Yeah.
But instead of doing that, I'd like to have you a human-sized kaleidoscope.
Pretty big.
Pretty big, and there it is right behind you. See the stairs?
Wow.
Climb up, and inside I have a stool. You can step on the stool. Okay.
It's a big kaleidoscope.
Okay, now hand me the stool. So you're in there all by yourself.
Oh,
What do you see?
I see lots of me.
Lots.
And they're all in lines.
Yeah, they're all over the
See,
place.
1, 2, 3, 4, 5.
Well, have fun. Count yourself, because I'm leaving.
Okay.
Bye.
I wonder which one of them is me. Is this me or is that me? Oh, friendly type.
Scientists can get a good idea how ancient people lived by piecing together clues at an archaeological dig, like this huge one in southern Illinois. The Shell Oil Company documented the activities. It looks like confusion, but it's all very carefully planned, so no valuable evidence is overlooked. It's fairly rare that large artifacts are found. Most of the time, the clues are quite small. That's why these workers save the fine mud they dig up at the site. It's carried to the nearby river and placed into large tubs that have screens on their bottoms. The river water washes away the very fine sand and dirt. What's left is saved and taken to the field laboratory set up in town not far from the excavation. Other team members sort the tiny debris. What's left of a nut is a clue to what the ancient people ate. Bone fragments indicate fish and small animals were also part of their diet. These tiny bits of evidence fit in with a rare, larger discovery. The students notify a supervising scientist if a larger artifact is uncovered, such as this grinding stone. More evidence of how the long-vanished people lived. Scientists have used the primitive techniques of the ancient peoples to recreate the same kind of tools uncovered at the site. Then they used the tools in the same way the vanished people probably did. Thus, the daily life of people who lived long, long ago can be reconstructed by scientists because they have pieced together clues found during an archaeological dig. Okay, dump the ice cubes in here.
Okay. Whoops.
Okay, now I would like you to fill that glass with ice cubes.
Okay.
Certainly full, right? In
Yeah.
fact, sticking over the top. Okay, next, I would like you to take these 2 glasses over to the sink and fill them both almost full of water. Then bring
Okay.
it back, okay? Okay. Now you notice I'm wiping off the table so there's not a drop of water on it.
Okay.
And I will wipe off this plate so there's not a drop of water on it.
Why?
Well, you'll find out in just a moment, because I would like you now to use this long medicine dropper and take water from there and fill this glass so that it's right to the very brim with water.
Okay.
Don't let it overflow, but get it right to the very top. Aha! That's it. Okay. Move these out of the way. Wipe everything up so there's no water anyplace. Now my question is, as the ice melts, will the water overflow over the top of the glass?
I think so.
Why?
Well, because like you have the water, and the water is filled to the top, and then you have the ice also, and like I think while the ice melts, it'll just overflow.
Okay, that's one theory, and that's definitely a theory, right?
Yeah.
You know what a theory is. Well, there's another theory, which I would like to advance and see how you like that. As you know, ice expands when it
Yeah.
freezes as compared to water. That's why ice floats, right?
Yeah.
Okay. So therefore, as the ice condenses, in other words, goes back into water, it should take up less space, therefore the water level will drop.
Okay, yeah, I see.
That's theory 2.
Yep.
Now there's a third theory. Obviously, the volume of the water is taking into consideration the ice that we've got in there. So as it melts, it's not going to change at all, because the volume has already got that ice floating in it.
Okay, I see.
That's the
Yeah.
third theory. Which one are you going to take?
Mine. My theory.
The first one?
Yep.
That it's going to overflow.
Yeah.
Okay, now that's why I wanted to wipe up everything so there's no water around any place.
I
We're going to let
see.
it sit there very carefully and melt. It'll take about 2 hours. Can we be back in 2 hours?
Sure.
And I promise I won't touch it.
Okay.
Okay?
Hi.
Hi, Karen. Hi, you're right on time. 2 hours. You're very punctual. Are you usually?
Most of the time.
Okay. There's the glass that had the ice in it. Don't touch the counter now.
It didn't melt.
And your theory was that it was going to melt and flow over the top, right?
Yeah.
And why was that?
Well, the ice, like it was floating above the top of the glass, so I thought it would melt. and-
Okay. That was
Go
one
over it.
theory. That was no good. Now, the second theory was that the ice expanded as it would change from water to ice,
Yeah.
therefore took up less space, so that as it melted, it would take up less space, so the water level ought to drop.
Yeah.
Did it?
No?
So the third theory, you remember now I told you that as you added water to the ice and you got it all to float, the level of the water took into effect the mass of the ice.
Yeah.
And therefore, as it melted, that water level is going to stay exactly the same. And that's what happened.
Yeah.
I assume, Bibi, that you've never played around with a laser.
No.
Well, that's what you and I are going to do today. What does a laser mean?
It's a beam of light.
Yes, a special beam of light. And here is the laser right here, or the machine that's producing the beam of light. And it's going out there just missing that mirror and bouncing back and forth between those two. And now we want to make them visible. And I know you've experimented with dry ice. So if I show you a bowl of dry ice and some warm water, you'll know what to do, right?
Yeah.
Make nice dry ice fog. Okay, now you get ready and you can sort of pour the fog over between the two mirrors and see if you can find the beams, and I'll turn out the light.
There it is.
See them?
Yeah.
Okay, meanwhile, I'll make another sort of generator that we can have a little better control. You find them?
Yeah.
See how they're nice and red?
Yeah.
Okay, here, give me that one. And you can now take this one. And now, here, I'll hold the bottle. You just work the front end. Now, there's the first beam coming between the two mirrors up there.
Yeah.
Okay, can you hold it down a little more like that, and I think you maybe see them all.
Okay.
Where is it? There's they are. Okay, there's number one. How many can you find?
1, 2, 3, 4, 5, 6, 7,
You move your
8.
end down a little bit, or up, one or the other.
There.
9. 9 beams all together.
Yeah.
Okay, so let's put this off the side. Let me turn on the light again. Okay, now, I have a challenge for you. First of all, I think you should understand one of the reasons why they use laser light is because it is a light of a single wavelength. In this case, red, right?
Yeah.
And you shouldn't look at the beam, by the way, but it won't hurt you when it hits your hand like that. It's a single wavelength of light, which means that it can also be very carefully controlled so that you can send a thin beam. Scientists had the laser here on Earth, and they sent the laser beam all the way up to the moon, hit a mirror, and it came all the way back down again. And that's my challenge to you.
To hit the moon?
Well, we won't do it all the way to the moon. Let's just do it across the room, okay? Now, over here are a bunch of wedges so that you can adjust not only the laser, but the two mirrors. And way across the room over there, you see there's a bullseye?
Yeah.
What I want you to do is start the laser over here, bounce it all the way across the room, bounce it all the way back over to here, and all the way back over there again, and hit the bullseye.
Okay.
Think you can do it?
Maybe.
Okay, so take that mirror and put it over there on the top of that thing over there. Okay, I have the laser now with a wedge under the front of it, so I'm sending a beam across the room over there. Okay, your challenge now is to send the beam back again twice and hit that bullseye. Here's the mirror. You take the mirror, and we'll go over and put it in that spot.
Okay. Oops.
See, there's the beam of light. Okay, now what do you have to do?
I have to move it so it hits someplace on that wall.
Right, where is it?
Right there.
Okay, there it is, too high, so that's why I have the wedge for you. Haha, there you got it.
It's a bit
Beautiful.
there.
Okay, now what's next?
I have to go over there.
And set that mirror
Okay.
so that it'll bounce back and hit this bullseye.
Yeah.
All right. Okay. A little too high. Let me pull that out.
That's too.
Okay, a little more to the left. Okay, you got it. Congratulations.
Thank
You
you.
did the same sort of thing that scientists did when they sent the laser beam all the way up to the moon and back, and they also sent it to the shuttle from Hawaii and hit it even though it was flying like mad through the air. They also used a beam like this in surveying and in lining up optical equipment, and so I thought it might be fun for you to do it. Congratulations. You hit the
you.
target.
Thank you.